Good afternoon, everyone. Thank you for still being here. I will be your last talker. So I'm Haibin Huang from the Institute of Artificial Intelligence at China Telecom. Today, I will present AI Flow, an AI infrastructure we have built for AI native communication. The basic idea is simple. For decades, communication means sending signals from one side to another. But the receiver is changing. It now has intelligence. So it could be a human, but it also could be an AI model, a robot, and an agent that can understand, decide, and act on its own. So here's the question one should ask. If the receiver can think, do we still need to send it everything as the old way? AI Flow is our answer. So let's start with two numbers that doesn't look real. With around 100 kilobytes per second, AI Flow can carry full HD video. And with around 275 bits per second, it can deliver live voice. Normally, those batteries are way below the physical limitation of traditional communication. So what happened? We didn't break the physical law and the Shannon theory, and we didn't magically make the channel larger. What we did is change what gets transmitted. We are not sending every pixel, every sound wave, and we are starting to send a compact representation that an intelligent receiver can understand and reconstruct on its own. That's the starting point of AI Flow, and I will show you how we work today. So let's go back to the classical communication model. So there is a sender and a receiver, and in the between it's a pipe. The sender encodes and modulates information. The pipe will transmit signals. The receiver will just decode the signal and try to recover whatever it receives. This model has worked extremely well, and it gives us mobile communication, satellite link, and internet. But it also makes a hidden assumption that the receiver is mostly passive. So for the decades, we are working on sender and pipe. We have better method for packing information, and we have better pipe to send them. And we have better network service from 1G to 5G. But for the receiver, its job is still to reproduce the signal, not to understand the thing or decide what matters. So that's why I will say we only do half of the dumbbell about communication. But we can see the receiver is changing. In the analog year, it has no intelligence, so it's just a simple speaker. But at the digital year, it has a screen and a decoder, so it has a little intelligence, but the final consumer is still a human eye or ear. So now, when we go to the 6G, the receiver could be still human, but it also could be an agent with intelligence. It could be a robot brain or on-device AI. It can think, decide, and act. So if it can think, do we still need to think the whole things? And the entire goal of communication should change with this receiver. So, and this is isn't something that in the far future. It's already well on the way. Computer at the receiving end is climbing for decades, and it's growing, still growing. So a receiver with real intelligence can do something that older receiver can never do. It could understand things, infer what's missing, and predict what's next, and decide what matters for its task. So that's the real shift. Receiver stop being the passive step of the decoding. It could be an active part of the communication. This also naturally connects to the Shannon-Weaver theory about levels of communication. At the level A, it's about technical accuracy. It wants to see if the samples arrive correctly. And at level B, it's about semantic. Did the receiver understand the meaning? And the final level is level C. It's about effectiveness. Can the receiver use the information to complete a task? So traditional communication is stronger at level A. But with the development of AI, the intelligence receiver forces us to care more about level B and C. So a human viewer may need to choose a full video for high quality, but a robot may just need about the things about motion. And a crowd agent may just need to extract the information for listening and decision. So instead of one target for every receiver, we ask a simple question. What kind of information and what level of information did the receiver need? So our answer is to transmit through a shared token space. So as you can see here, when the same source thing can send different things to different receiver. For humans, we may need the full thing and with appearance, identity, and semantics. But for a robot, it may just need where the object is, the layout, the action, and the code. And for the crowd agent, it may just need the goal and about the water state. So instead of sending everything as the same, it's better to decide based on the receiver, the token, and the thing. So we think AI flow is a new way to unify the ABC level communication with a shared token space. So this also led us to move from bit flow to token flow. So communication is no longer about moving bytes through a pipe. It will be about moving useful information through the intelligent system. And in the bit flow, the sender tries to transmit zeros and ones, and the receiver tries to reproduce them. But in token flow, the sender transmits meaningful units. The units could be representations of objects and motions, sound events, and scene structures. The receiver then can generate, reason, and act based on what it received. Of course, those tokens are still need the physical channels. We still need bytes, coding, and networks. But the whole design object moves one step further. So from exactly channel signal reproduction, and we move it to the useful information and action. This is why airflow is not simply a comparison method, but a whole way to think about how we can communicate. So why do we use tokens? There are 4 reasons about it. First, it is the natural language for modern AI models. Second, it has the forgiving by nature, so even the network is a bit with low bandwidth, it lost some bytes, but due to the nature of tokens, a large model still can to infer and generate by its context. And third, of course, by tokens we can use much more compact representation to encode both videos, audios, images, sensor data, and they all become in one space. So instead of transmit every pixel, we can transmit tokens. So last but not least, it can directly used for those different tasks for humans, for machines, or for decision making. So given that, we still have 3 problems to solve with AI flow. So we needed to say how should we represent a word and how much information we can remaining when we use compact and understandable tokens. Second, what to send. So giving a task, what should we send? And how to reconstruct. Once the receiver gets these tokens, how should they to reconstruct, or even with partial or noisy tokens? So for the first one, we want a compact and a generative and understandable representation for the tokens. That motivates us to use a unified generative model that it can both understand and generate. So it can represent all the multimodal input as in a shared token space. Also, we'll use the information capacity theory to decide what kind of model we can develop based on what kind of tokens we have. It leads us to a bigger model, but with few tokens. Second, we need to decide what to send once we have those tokens. Different tasks may need different information. For example, for humans, it needs the whole information, both the texture, motions, for human to view. And for robots, it may just need to know the path about obstacles and motions. And for emergency rescues, the agent may need to know where the people is, where the fire is, those most important objects. And also the channel also matters. When the bandwidth is good, we can see the more details. But when the bandwidth is limited, we can send only the most task-relevant tokens. So the receiver also matters. A strong receiver, it can use less tokens to generate more complicated things. So instead of sending every pixel as usual, we should ask what task you have, what bandwidth you have, and what kind of receiver you are facing. So this gives us to define a series of model. On device, we have a small model to extract local tokens. And in the edge device, it has more intelligence, so we can refine them. And as a cloud, we have the largest model. It collects everything from different sources and generates the final results. So they all work together as at a shared token space. And we believe the network should be distributed intelligence, so to make a modern network. The third problem is how could you reconstruct the world when you get those tokens? Because in the real world, tokens may be missing, they could be delayed, and they corrupt. So the receiver still need to reconstruct, use this information. So here we use two ideas. One is to using the positive incident noise. Usually people treat noise as harm to the model, but we found that with sufficient noise, it helps us to understand better about the background. And in that way, we can send less information. Another one is we use the robustness of generative model. Since a generative model can infer from the context, so even we have some token missing, it still can generate a smooth results without interrupting a network. So given this, let me show you the results. We use Airflow for video transmission. On the left is the original video at a high resolution. And traditionally, we need like around 4 megabytes per second to deliver this. But with generative transmission, we just load down it to 100 kilobytes per second with relatively good PSNR and LPX, which means we keep both the visual quality and the semantic. The same thing happened to the audio. We can use the same way to transmit video, audio. Here, and the results will be more extreme than the videos. And let me show you. So here is concert level audio. Details. So usually it needed to have a bandwidth up to around 500 kilobytes per second. And if we try to send this in traditional satellite bandwidth, it will be like this. The sound will be broken, and you can have no idea about what it is sending. Okay, so with our generative audio, it can load to 275 bytes per second, less than 1K. So let's see how it works. So basically, you cannot tell the difference between the reconstructed one and the original one. But with like thousands less bandwidth. So now let's move from the theory to some applications. So the first group will still serve for humans. People still need to watch or hear the audios. But in these scenarios, the link is so limited that the traditional transmissions becomes unusable, such as the drone to satellite connection and at the disaster zones or underwater. Airflow gives us options to make those still sending the useful information and keep the system working. So first, let me show our drone to satellite connection solution. So based on Airflow, we develop a system that enable direct video transmission from a drone to a satellite link. The key challenge is here the satellite link is so limited, and for commercial drone, you cannot carry too heavy edge device. So we develop a lightweight edge device for this and for generative transmission. So this edge device will extract useful information based on the drone view and then send it through the satellite link. So let me show you the demo.
Snow-capped mountains, deserts, crew members at sea, emergency rescues. In these extreme and challenging environments, signal is weak and networks often fail. Real-time video from the field cannot be transmitted back, making it difficult for command centers to make timely decisions. To solve this, China Telecom's AI Research Institute has developed the AI Flow Generative Intelligent Transmission Box. This compact device can be carried by small drones and connects directly to satellites, enabling real-time, stable transmission of high-definition video, even under narrow bandwidth conditions. AI Flow breaks from traditional communication methods by using computation to replace bandwidth. Instead of transmitting raw video pixels, It sends tokenized semantic information, capturing the meaning, features, and context of the video.
As you can see,
After satellite relay, multimodal generative technology
bit rate
reconstructs
is
the images.
around 100
Tests show
for
that at an
high
average of just 60
dynamic video.
Kbps, AI Flow can stream 720p HD video in real time, ensuring smooth information flow in disconnected scenarios and bringing critical visuals directly to your eyes.
So the same application can also apply to the disaster zone where there's no 4G or 5G connection. But with our method, it can still deliver useful information for rescue team to decide where is the most dangerous one. And when the bandwidth is so limited, you can still send by pictures. So we can compress a high resolution image into like 5K or even less. This could help the rescue team to decide where they should go. Also, the third scenario is underwater communication. Traditionally, this is always very limited. So with our self-developed device and AI Flow, we can now see what's going on underwater. Let me show you the device demo.
Underwater communication faces a fundamental challenge: extremely limited bandwidth. Traditionally, acoustic links beneath the surface have been restricted to transmitting text, commands, or very small data packets. Sending images or video over long distances underwater was nearly impossible. Now, with the introduction of AI Flow technology, this barrier is being overcome. By transmitting compact, intelligent tokens through acoustic signals, the system enables receivers to reconstruct detailed image-like or video-like information. This breakthrough transforms the way data is shared underwater.
Yeah, as you can
This
see,
advanced
we can
communication
see the
supports a
underwater
wide range
even
of
with those
applications,
fish.
from divers and underwater robots to ships and environmental monitoring systems. Instead of relying solely on text-based messages, users gain rich visual insights, enhancing situational awareness and operational efficiency beneath the waves. By expanding the capabilities of underwater communication, AI Flow opens new possibilities for exploration, safety, and data collection in marine environments, marking a significant leap forward in underwater technology.
So the next one is about everyday stream storage. As you may see, the storage cost has become a more serious issue, especially to the system that keeps large amount of video. So as you can see, with our method, we can keep the video at the same level of quality. For most human users, they cannot tell the difference. But with about more than 40 times better compression rate with respect to the traditional method. So far, we are talking about human to human, but now is the AI time, so we need to think about what AI Flow can do when the receiver is not a human, but an AI. So it's basically more about the decision, not the perceptual quality. And it still needs good tokens to help them to decide. And again, the communication is no longer just sending information, but it will become the part of the intelligence. So here is human to robot communication in the teleoperation.
Teleoperation allows a human operator to control a remote robot with precision, even from a distance. Maintaining a stable communication link is critical. Any video lag or control delay can disrupt the task. AI Flow enhances this by reducing data transmission needs, focusing on essential visual and control elements like obstacles, tool positions, and motion. This targeted approach ensures smooth, reliable operation, even over weak or unstable networks.
Okay. So the next is about collaborations with different multiple agents. So here we demonstrate a task that we ask two robots to carry water.
In this, A user asks the robot team for help getting water. The request is shared through a robot communication group, then converted into a coordinated task. One robot navigates toward the target area, while another robot shares status and supports the handoff. The team exchanges compact task
So
tokens,
the agent will
location,
share their
route,
information
object status,
about
and
where is the
progress.
location
This shows
and
how
the
shared
overall
intelligence
map
helps robots
through the
cooperate and
tokens.
complete real-world service tasks.
Okay, so the next one is about act with a group of agents. We use so the group of drone will form a group to search for the key. They will search the area and see where share the information where they have already reached or where will the key be. They are cooperate together to search the whole space. Okay, so those are the application demos. And for one more thing, we think AI flow is not a replacement of the network communication, but it's a complementary method. So even with the 6G or satellite communication, as people always say, the bandwidth will become much more wider. But as you can see, even with the widest highways, there are still traffic jams. So we think AI flow is one way to improve the efficiency for communication. And it could benefit both the 6G or the satellite links. So let me summarize in 3 points. First, we believe the receiver become more intelligent. So communication should be on just the sender and pipe. The receiver should be part of the communication. And we also believe tokens carry means. So a compact and semantic representation could support different tasks, and they can be in the shared token space. And we also think with our AI flow, we try to use a unified model, adaptive transmission, and generative recovery for different tasks. And the AI flow tries to connect the intelligence. So network should not only connect device, they should try to connect intelligent agents. And we think through connection and interaction, there will be next intelligent emergence, just like the large models. Now, none of this work can do in one person. So I want to thank the entire team at TeleAI. It's the AI Research Institute at China Telecom. It was led and founded by Professor Dr. Xuanrong Li, and he also has those information capacity and also the whole framework of AI flow. So thank you, and AI flow is our attempt to rethink communication at the age of intelligence. And so if you feel our work is interesting, you could connect us through Twitter, and we are looking forward to your discussion and questions. Thank you.